Yo, good morning. So we're in the process of adding back the terraforming to the game, and during yesterday's implementation of it, we identified a little bit of a weak point concerning the terrain data texture container. Previously we had one, or I thought it would be smart to have one terrain data texture container and one terrain data render texture container, and have it as straightforward as terrain data texture container is available both on GPU and CPU. Terrain data render texture container is only available on the GPU. But turns out we can't really blit with a texture 2D as the destination. So instead, I think it's a better option to just merge these two. Terrain data texture container is GPU only by default, but then if we call methods like value or value byte or something like that, and this flag dirty is true, i.e. we have changed the GPU side of things, then we need to read it back, and then we do it like this. So we just copy texture. Makes me wonder though. Yeah, we're gonna have to do it like this, and then we will probably need to read it back to the CPU as well. We'll see. Yeah, it's on GPU only. I'm a little bit, so we probably want to use this one. But async, I don't know. Kai what's up? Good luck with your work. Thank you, appreciate it. You too, with whatever you do. Like, I would love to use this one, but the only problem is we need it synced, I would guess. Because the problem is that we need it quickly. But we could try this. Maybe we'll get some small problems, but maybe we can even wait on this one actually. Ref native array. Okay, beautiful. So like this is, oh, I want this callback. This is beautiful. I love this method, but maybe, just maybe not for our use case. But like the thing is, a lot of these things, value byte, value normalized, set value, etc., etc., they are, we pretty much only use them, they're only here for debugging purposes currently. So in the actual game, we will never need a method like this. We don't need, or let's put it this way, we do need values like this, but not on a short notice, so to speak. So when we alter the terrain, we are going to have a second thread later on that analyzes the terrain. So how much of the terrain is grass, how much is, like, we want to analyze the full terrain and see we have X percentage of grass, Y percentage of tall grass, we have Z percent water, and so on and so on. But this analytic method, it doesn't really, we don't need it to be instantaneous, you know? It's okay if it's delayed a couple of frames. That's why we can do it on a second thread on the CPU. And if we did need the data on the CPU then to do these calculations, we don't need don't need to get this right away. So it's okay if it waits. So I'm actually going to add a new issue here because I want to, whatever I've said here, I want to implement it down the road. But for now, we're actually going to go with a very slow solution here. Or we can do, and then we can see the, and then we'll reference that issue eventually. So let's create that issue real quick. Like, this is beautiful. It feels like a lot of things are coming together right about now. Let's see here. Optimize. So I'm going to bring it over here. Oops. Let's bring it over soon. Here we go. Yo, good morning, Harukanan. Hope you have a wonderful Tuesday so far. Oops. Um, um, Something like that. With, and we're gonna have to do read pixels now. Ah, beautiful. But then we don't want to have these here. We want to have them. Is it that reference we get, really? Okay, let's do it like this then. Let's see. How the canon was good. I had a million to do things sequenced in my head. Can't recall about some minor thing I did not have had to get involved in. My entire sequence was erased for no reason. Been there, been there. Back to stage one. Beautiful. Now we save this one. And we're gonna do it later. Non-coders have no idea how bad they can fuck up by asking us a stupid question. Yeah, losing a train of thought is... Ooh, yeah, it hurts. But hey, we can also exercise so that we don't as easily lose that train of thought, right? I've noticed that when when you have young kids and you want to do some programming while taking care of them, you're gonna have to learn that skill set. That's for sure. Okay, so we're not gonna do copy texture. Instead, when we do fetch data from GPU here right now, oh, actually, I wanna reference this one as well. 157. Oh, look at this, I thought. I haven't... Okay, so this one hasn't updated just yet. I wish I had a git stash command in my brain station. Me too, me too. Okay, so for now, let's rely on this slow one. We read pixels to the active render target. So we're gonna have to do graphics dot set render target. I thought texture copy. Or do we really need to have render texture? But fuck, here we have the same. No. From the current render target and write some texture. Okay, beautiful. Set render target. We want to set texture. Texture. And then we do texture copy dot read pixels. Source. Do we really need a rect here? Oh no. Okay, so rect only takes X. Come on. So we do it like this, and we want one more thing here. Destination X, destination Y, 0, 0, I guess. Recalculate mip maps. We don't care about mip maps here. I don't know what the default here is, but we're gonna set false. And that's how we do it. But only if it's dirty, right? Okay. Let us run the target. Get pixel data. Get pixel data. Set value. Here we're gonna have to do it a little bit differently. We're gonna have to do this first. And then I wonder... Yeah, we're gonna have to do apply here. Set material properties. Generate values. So pretty much want modify. Okay, generate values. This will probably do on the GPU as well later on. That would be amazing. Clear. Don't we have texture dot? Okay. Oh, I love this one. But we need a command buffer there. I'm not so keen. I'm not so keen on having to send in command buffers at all times. So I wonder how bad would it be to do new command buffer. We definitely don't want to do new command buffer, but I wonder if we can do pool. Let's double check that one. I want more information, more information. Okay, let's leave it here, but so clear, for instance, instead we're just gonna do command buffer pool.get. And then we do buffer.clear render target. But so first we want to do set render target texture. We don't have a depth here. Clear color, true, background color. Something like that. Clear. We need to fix apply, save load. I don't care now. Generate values. Let's wait with that one. But when we set value, yeah, we want to do apply here as well. And I think we're just gonna leave it like this. I need to read up on getting command buffers and stuff like that. We don't want to leave anything hanging eventually, but whatever. Okay, apply. So it's very important that after we have done generate values, that we call apply, which we do. And yeah, then we only have these two. Okay, so that's good. And then set value. This one is a little bit, I don't even know if we call this one destination buffer. Move terrain data. Do we do apply after all of this? Yeah, all of these are old and we will hopefully not use them soon enough. Yo, what's up, Cooler SK? Yeah, we call apply terrain data here later on. Okay. I wonder if that's about it. We have some compiler errors we need to take care of because previously we had render texture container and texture container. Now we only have texture container. And then we did it like this. Yeah, this is one of those things. Here I would like to obscure it a little bit more. Let's see if we can do that. Rain base. It's because we want to set render target. So I wonder if we want to do... Yeah, fuck this. We're gonna do... We're gonna do this instead. I've never liked this one. Clean up and obscure. It's a little bit cleaned up. Generate MIPS. Yeah, we want to do something here as well. Let's see. We're gonna do... generate values. What do I want to call this one? I'm just gonna call it like this for now. Like, I wonder what the pros and cons are of just using one command buffer. We have more control of when we... That's true, when we execute it and stuff like that, but... Generate secondary data. For this one, for now, we're just going to do implement. I have no idea how I want to handle secondary data for a compute buffer, but we'll find out. Generate values. Generate secondary data, and here we just do command buffer dot generate MIPS. One more thing. We need to set the dirty flag as well. And we're going to get to that soon. Terrain base. So instead here we do, in fact, let's do it like this. Okay. So yeah, we need to set dirty to true when that is the case. And currently that is the case here. It's here. Eventually. We're gonna fix this one soon. Not on apply though. On clear. Okay. Yo, what's up, Neozoid? This is probably just something hanging around. I cannot convert. Come on. Oh yeah, okay, we have this one. That's okay. And this one. So activity direction, strength. Here we just want to do terrain, data, texture, container. What's up? I'm feeling good. We're cleaning up the terrain data containers, which I like. Improvements upon improvements upon improvements. Refining. What's up with you? So the problem we have here is this one, ARGB float. ARGB, don't we have ARGB? So float, is that actually, I wonder if it's 16 or 32. It's probably, yeah, let's take a look at graphics format. Sounds cool to me. Yeah, it feels pretty cool as well. Okay. I guess we want to do R32. This one, a 4-component. 128 is fucking overkill though. But we need 16 at least, I think. Yeah, this one, I think. Signed float. We don't care about signed float. Do we have just float? Unsigned, unsigned, unsigned. Or actually, can you have it? Ooh, 24-bit unsigned normalized format. This is probably what we want. R16G, 16B, 16A, 16U norm. Values between 0 and 1, I suppose. Yeah, let's go with this one. Okay, so how many does it take? Bool MIP chain, macro type, width, height, graphics format, MIP chain. True. Yeah, we do all of these as, so this time around we do all of these as sRGB false. Height, foliage. Okay, texture format. We want to change this one as well. So we want to go graphics format dot R16. What do we have here? R16, sfloat, sint, snorm, uint, unorm. Unorm. And we want to do the same here, I reckon. Okay. I don't know. Let's see if this works. Okay, so let's take a quick look at the pipeline if I've missed anything. So it's gonna be, we're gonna start this off with action, interaction, terraform. And here we have some action logic. We don't care about that now. I think it works. We assume it works. It worked last time. It worked on my machine. But then we can trigger terraform, and what we do then is we get terrain base. If we have terrain base, we call terraform. This is probably the pipeline we want to do. So identify terrain patches, and then for each terrain patch. So we identify terrain patches, and then for each terrain patch we do set up properties in terrain brush material. We do it here. We're going to clean this up soon enough, make it look a little bit better. We don't want to have these magic strings or whatever. I want to rename these, maybe, possibly. But we do this, and then we do call modify on data. And here we have terrain data, terrain patch dot data, the type we currently have on the brush, so height, foliage, whatever. And then we call modify, we send in terrain command buffer, and the brushing question. This I don't know, but we'll see. And then finally, when we have, yeah, so here we populate the command buffer. I want to double check modify on texture container. So we just do a blit from the brush texture to, yeah, this one we want to fix. Here we just want to replace this one with texture. And then the brush material, and then with set dirty to true. I think that's it. One more thing, however. Terrain base. Okay, so this one, our height collider is currently just a mesh collider behind the scenes, but eventually it's going to be a height collider. So instead of building a mesh and doing collision, so building the mesh, pretty expensive and stuff like that. We're just going to have the height data on the CPU and fetch specific indices, pretty much. Neozoid, keep it up, dude. Thank you. I will try. See you later. Thank you for stopping by. Appreciate it. Appreciate it. Please leave a like. Helps a lot. So update height collider. This is what I want to do as well. In the end, and this is like, so if we have this as a proper height collider eventually, we are gonna do, that's what probably one we're gonna rely on. We can take this one a lot. So when we change the height data, we're gonna flag it as CPU dependent or something like that. So every time we change it on the GPU, we're actually gonna read it back to the CPU. Keep it fresh. And like, if it's height data, it's okay if it's a little bit slow. Because what will happen is we will start reading it back, but while we're reading it back, we might use the old height values. So worst case scenario, the character or the characters will clip through the ground a short while. It shouldn't be too bad. We can do some nice stuff with it. But yeah, we want to update the height collider, and I wonder, terrain patch. Height collider. We only instantiate here and then don't do anything else. Alter terrain data. This one is old. We're not gonna work with this. Maybe. Fuck. Maybe it's cleaner to use this one than to do it out here. Yeah, maybe. We can probably do something nice here eventually, but question mark. Generate Terraform data. This is old. Fuck this. Fuck this. I like this one. Yeah, we're gonna do this. And then I want terrain data type. Do we have... Is mesh dependent? Yeah. Effects or effects? Effects, I think. Uh, update collider. There we go. Hmm. Struct. Do we store UV? No, we don't. But do I want to keep UVs here? Maybe I do. Yep, why not? We're gonna get rid of all of this eventually anyway. Or maybe use it for something else, I don't know. Okay, and then what I want to do is update collider points. Yeah, we want to make this a void. Can we do this? It's bad, but yeah, we don't have triangles here. That's true. But maybe we can do... Yeah. And we do this. Update collider point. This we don't need to do all the time, not this one either, so we can go like this. Yeah, Max resolution here. Clamp, okay. Okay, so update collider points. Basically, we just want to do I guess we might as well create a new one. But we can do it like this. Update collider points, we need to send in this one. But here I want to do yeah. That's not the one I want. I want what is it called? Height collider point. Okay, so we do all of this, update everything, and then finally we do update. Not here. Update collider. Here we do update collider points. This one, we don't care about this one being texture. Data. Do we care about height? No, we don't. Not anymore. So update collider point, and finally update mesh. So terrain patch, terraform, if brush affects collision, height collider dot update collider, and we send in. Yo, good morning, Cynic. Hope you're feeling better today. Terrain data container. Okay. Now I think we finally have everything from start to finish when it comes to Terraform with this new system. I don't know, any compile errors? Let's see. Yes. Terrain patch terraformer. This is something we used previously. I want to delete this shit. But let's see if I'm missing something. Cynic a bit will do some work today. Can think at least now. That's good. That's a good sign. Yeah, when you're sick, you really don't want it to move in the opposite direction, right? Getting worse by the day. That sucks. Generate Terraform data. We don't really care about Terraform data either. Like, this is... Yeah, we do this in a much better way now. Apply Terraform brush boundaries, error margin, alter terrain data is mesh dependent. I think we can do delete. I think we can delete Terraform data and Terraform data row as well. Would be so nice. Do we have any compile errors? Okay, let's try this. The worst that can happen is a crash, I suppose. And the next worst thing is this. Okay, index 8580 is out of range. Oh no, do we have this again? Okay, I'm wondering about the data size here. We will check this one soon. Yo, what's up, Jax? And yeah, since this one fails, everything else fails. So I want to double check this one. $8580 is out of range, $8580. So we have the same. I want to see, where does this one come from? Terrain patch 17. Okay, this is weird. So this is during our generation phase. I didn't think we changed anything related to this, but you never know. Probably this one. Float, yes. Okay, I think... yeah, this is something we're gonna have to work on eventually as well. We're gonna have to make it dependent on whatever graphics format we do here. So sometimes it can be float, sometimes it's byte. The problem we have is that we create this one with R16U norm. What did we have previously here? Texture format R8. Yeah, that's very old. Float is 32 bits, right? Oh, don't we have this one? Why the fuck don't we have a 32U norm? Am I missing something here? What happens if we go with this one then? Do we need to set this one? I was a little bit worried about that one. What the fuck? Why were we failing on generate? What have I changed that should have that could affect this? Hmm. Non-finite value. Ooh, actually. Hmm. I'm a little bit worried about that one, but I also think that we might have an issue here. Could it be? Could it be? Could it be? Generate values. Two different errors. Or two different causes. I think we can focus on this one first. We try to get data value. So this one. So when we try to read this one, this returns not a number. That's not good. I wonder if it's because we want to do texture. We can start with this one, but I'm also when we generate these values, we never, or actually we do a blit after, right? Yeah, we do. Could it be... Yeah, okay, nice. This is one thing I forgot to do. We also need to add new vertex attribute descriptor, vertex attribute dot text chord 0 float. But is it float 32? I think so. That's also extremely overkill. But yeah, all of this is temporary, so whatever. Okay, so this was definitely one issue. Ooh, okay. We get a little bit further along. Render texture does not have MIP maps. Set use MIP map to true. Yes. Let's do it. I thought we have MIP chain. We do descriptor here. So this is MIP count. I want to double check this one if I've understood it correctly. -1 should imply all of them. But then we also need to set amount of MIPs to allocate for the render texture. No. Yeah, I think so, but we can go with this one instead. But if we check here, can be used with texture constructors that take a MIP count to indicate that all MIPs should be generated. The value of this field is -1. But this looks a little bit cleaner, I think. And then we want to do descriptor. I wonder if it's weird to set this first and then use MIP map is equal to MIP chain. Auto generate MIPs we might want to disable as well. Yeah, I want to control it, I think. I don't know how all... Okay, so when we modify textures on the GPU, right now we just do it by simple blit. We could probably just let the MIPs auto-generate. But then again, we might want to stack changes before we generate them, right? Yeah. That's another option to set. Okay, this is cool because I think our we don't render the terrain as having height, but we can see that our collider actually gets height. So this is cool. I wonder why. Can we check? And look at this. So, why doesn't this render with an offset? Terrain base, instantiate, set layer generate. If it contains height, take the data, UV offset. Ooh, we can probably... Ooh, this, we can make this much nicer, I think. I want to double check that as well. Because if we can take all of these, I know that we do these calculations on a lot of different places. We just want to define these exact calculations in one place and then use that over and over. So we only need to change it in one place. And that place should currently be here. So we're going to double check that soon. Here we generate the values for the data and here we apply it. Clear, apply. And here we set the height collider. So at this point, we actually have the correct data. But then I guess when we do set material here, we do material, copy properties, set material properties. That's beautiful. But we should also do set material properties, set texture, shader property name, texture. So it's almost like we don't have the data on the GPU just yet. Graphic split. We do apply. Okay, let me double check one thing. Okay, interesting. We don't have any data here. Terrain debug material. Or actually, let's do... Why don't we have any data? Mhm. Is this not enough? We don't add, or we don't set, we don't use a custom material here, so it should. Unity uses a default material. I wanna believe that that default material works. Mm. Yeah, we know that this one has the correct data. Oh, could it be? Fuck. Yeah, this is temporary as well. We only have it on the GPU right now, or on the CPU, I mean. So I reckon that we need to do... Yeah. Okay. Okay. Let's see what we get. A little bit too strong. We get this error at edges, and we don't have an update on the collider. Okay. No errors, though. That's good. I'm a little bit worried. Yeah, the UVs are fucked. Here it worked pretty good. No idea what's going on here. Okay. Yeah. Hmm. It's not too far off, actually. We have a little bit of a wrong offset, and then we have these artifacts. But apart from that, yeah, and we have... it's way too strong as well. But... still a little bit better than I thought it would be. Way quicker, but we don't update the collider just yet, so... And we only get... and it's always in the... what is it? Positive Z and positive X, we get these lines. No, we actually get it negative as well. Okay. Okay, so the problem we have is... fuck, it was one thing I wanted to fix here real quick first. This one. We're gonna fix this one, or replace this one. But then I'm pretty sure the problem we're seeing is entirely tied to these two lines. I'm pretty sure. We need to fix the brush strength as well. But... yeah, let's just clean this up first. So UV offset test and UV scale test. Do we have... so this is base resolution. Base resolution. So we do base 1 divided by base resolution. think we want to change this one to 1 divided by data.type dot base, not get type. No. Vector 2 int. We should be able to do it with let's do it like this then. Okay, so in all of this is pretty much what I definitely hoped it wouldn't be, but it's pretty clear. UV min, UV max, and it's basically all it comes down to is it's a mismatch between this right here. So our terrain texture, our brush, we have a little bit of an offset here. So when we calculate, we want to calculate this area here. It's being calculated in the wrong way. I want to double check. I want to get some more information, but to make it easier to get some information here, we're going to go to Terraform shader and brush strength. We're going to set this one as well. I think we do it brush material, brush strength. So we should be able to just use it down here like we did previously. I wonder why we're getting... Oh, it's not far off as... Do we only have a... I guess it depends on where we stand. But it looks like we only have a offset. And then we have this problem, that's true. But it does look like we only have an offset in the Z direction, I think. Nah, that's not true. But actually, the fact that we don't change... we only change one of them. That might be very helpful. Let's see. Terrain patch 1213, 0.72, 0, 0.9, 0.07. Okay, so the closer to the center we are, the better it works. Okay. Actually, I'm a little bit afraid that... Yeah. Yeah, we have an offset problem, that's for sure. We have this line as well. But the fact that we don't... Where do we have an overlap? Here. fact that we only change one might be this. So we just queue stuff here and then we actually change. I want to see what happens if we do. Definitely would like to just add them all to the command buffer, and then when all commands are added, that's when we execute the command buffer. But it might be that the material. So the last coordinate properties we add is the one that is true for all of them. But still. Yeah, maybe. Okay, and we can see here that the offset is fucked. So now we alter 2, but the offset is screwed up. Okay, this is good. This line, what the fuck? Okay, I want to focus on these artifacts first, the line artifacts. I think they are the easiest to solve. But honestly, I have no idea what causes them. Probably something with this, but we'll see. Terraform. This one. Oh, UV boundary step error margin. this one here to UV step error margin. Set brush error margin. Do we ever call this one this time around? No, we don't. So this one should be 0. Wonder if we set it to, if it's set to anything by default. Hmm. 0.5. Just want to see what kind of result we get with this. 0.5. Maybe. Okay, so that's that issue. Now we just have this tiny bit of offset to fix. And hopefully if we fix that offset, we will also fix this. I think this is purely offset based. But this problem. So it's when we calculate input UV. In fact, do we need to scale this one as well? Maybe we do. Oh, Cynic, sorry, yeah, I missed it. What's the likelihood of Docker running on Linux? It's probably gonna be pretty likely. That's like my like that's the second platform in line, I think. You want it to run well on Linux, right? If you want it to be, if you want it to run well on Steam Deck, and I definitely want it to run well on Steam Deck. That's for sure. But that's a future me problem. Okay, I'm wondering if this input UV here. Oh, no. I wonder if it's this one or this one we care about. Input UV. Yo, what's up, Meister K? How you doing? Yeah, exactly. If you make it run natively on Linux, you will run on Steam Deck. Yeah. And so that's definitely a goal. Okay, so my first question here is, or my main question here, we know that we have some scale issue here, right? Or some offset issue. It doesn't matter what we name the issue in question. So my question then is it these two that are calculated the wrong way? Or is it these we need to scale and offset? Input UV My Doki official name? Nah, unfortunately not. It's a working title. I think there already exists a pretty famous name with that name, doesn't it? Or something similar. Doki Doki Literature Club. But it's the working name up here. Yeah, I haven't played it. Doki Doki Literature Club, but I don't know if we want to. Maybe it's a good game. That looks like a NFS. Yeah, that's what I'm wondering. What's up, Calvino? Yeah, we're gonna try and avoid getting sued. Naming is like I'm having a hard time naming variables. So naming a game is always fuck. I hate it. I hate it and I love it. Okay, I think we can I think we actually print these, so we can just double check. UV min, UV max. Yes, we do. So let's run towards the edge and try it. Where are we? I want to run down here. So we're right on track. Oh no, actually down here. I should add a teleport command when we're working with terrains this big. But let's see. Holy shit. Yeah, that's an offset we don't want to see. So what do we have? One sec, yeah. 005, 005, 010, 010. Yeah, that's definitely wrong. We should have seen 00 to 0, 00 to 005, I think. Something like that. Roughly. Okay. Literature. I'm having an extremely hard time pronouncing that word. Cynic always use ChatGPT for naming projects and stuff. It goes from dating sim to horror when you least expect it. I can recommend watching a playthrough. Yeah, maybe I will. I've actually, like, so that name, or that game has... I have seen it mentioned a couple of times. I think it's a pretty well-received game. So I will try and get a few hours of sleep again. Alright, thank you for dropping by, and enjoy that sleep. I love when games switch theme or category or genre halfway through. Or sometimes I love it. Okay, so how do we calculate these bounds? This or this is wrong, or both. Probably both. Yeah, the game is well received, but from a quick glance it looks like your average. And that's, yeah, definitely. Yeah, I just did a quick Google, and okay, I'm just gonna have to stock up on coffee here, because I think this problem is gonna be one of those head-banging ones. But when we have this, when this is fixed, this one, then we can finally close this issue, because then I'm happy with the full pipeline. Oh, look at this, we already mentioned it here. Beautiful. And this has been... Okay. So, do I need to do some drawings? Maybe I do. Okay. I have some jazz playlists playing as well, probably with copyrighted music, so I'm not streaming that one. But some of these songs are extremely good and relaxing. But some of these, what the fuck? Sounds crazy. Okay, there we go. And this is our data texture. UV, UV, UV. So this UV right here, when we do a blit, I wonder if we get, I think we get the UVs from the, I think these are the UVs of the destination texture. I'm gonna assume that is the case. So we go from here to here. Let's color this one. But that's not the color I want. UV.X. UV.Y. Okay. So the idea is basically the idea is basically that UV boundary brush bottom and UV boundary brush top right is let's Is this one? This is pretty simple, and I think this is a pretty nice way of doing it. Clean way of doing it. Best would be if we could do a blit, a partial blit, if we could just blit on a portion of the texture. But basically, so this is a vector 2, this is a vector 2, or float 2. And these values should be display or be the UVs of this texture in let me just see this message here. One sec. Okay, so the UVs we get in here are these UVs, go from 0 to 1 and 0 to 1. And pretty much what we, and then we calculate brush UVs here. Or we check is within bounds, because what we want to, yeah, so UV boundary bottom left and UV boundary top right is basically the UVs of this texture explained in or represented in the space of this texture. So UV boundary bottom left here would probably be minus 0.15 maybe. So this one is minus 0.15 and 0.85 maybe. And this one is 0.15, 1.20-ish, you see? And this we have done on the CPU, and I think it's this. I'm screwing these calculations up. Because if that were the case, if they were what I say they are, then we do a check here. We just check, so we're gonna go through every pixel on this texture, and we do it in parallel, right? So we check this picture, this pixel, is this UV for this pixel within these bounds? No, 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 and we do this in parallel, GPU stuff. And then we get up to here. Is this pixel within the bounds? Yes, it is. So it is, so we go down to this code right here. So what we do then is we calculate a brush UV, because now we want to read from the brush texture. So that means that we need to convert input UVs to brush UVs. So this brush also has some UVs, brush UVs. Let's see if I can. Where do I want to put that? right? And an easy way to do this is what we're doing here. We're doing inverse lerp. So we take this point, we have the UV here. So then we take inverse lerp of the x between this one and this one. So we get a value between 0 and 1, which corresponds to somewhere on the texture. And then we do the same thing with this one. So I think the calculations is correct. We have had this working with the previous Terraform system. So I think the calculations are correct, or the approach, the logic here. But everything fails because these are wrong. And I pretty much expected this because we're doing so many weird offsetting and scaling and stuff like that. We have, so it was a big issue yesterday with this right here. Every colored grid here is a different terrain data texture, 7 times 7. The whites here are the, is that a bad word? The white squares here are the terrain patches. And we always have one line of pixels as padding. And then we also have half a pixel of padding to get the vertices to be located in the center of pixels. It's a whole thing. And then we have all of these different spaces to keep into account. So we have gone from position in world space, normalized, and then to UV, and so on and so on. And somewhere along this line, we fail. I fail. And I'm pretty sure it's at the end here. That's why I highlighted these lines. I'm pretty sure this is where I screw up. Okay. Terrain patch bounds min, x, and z. Let's take a look at what this actually is. The bounds are the mesh bounds. So we're talking object space here, but in our case this is actually world space, I think. Or it's object space, but then we add position here, which makes it world space. We don't have any scaling or rotation. Thank God. Okay, so this is object space. So pretty much, yes. Okay, so what I think I'm doing here is we take the min point. I'm actually calculating, so what I think I'm doing here is calculating, so for this white square, for instance, we're calculating this position in world space. And we're calculating, or actually this, and this together is this point in world space. This and this together is this space in world space. And what I think, or what I thought I was doing with this and this is scale and offset this point, for instance, the minimum one, to be this point. So I'm pretty much trying to visualize or make it so that the texture in question exists in world space as well. And we extend the boundaries of the terrain patch to make it include the full texture in world space. Maybe a bit weird. I wonder if an easier option would be to do Because the fact is, like, we want to alter these margins as well when we terraform. This is an edge terrain patch, so these are basically just used for calculating the normal and stuff. But we also have an overlap here with this padding with this one, so it's extremely important that these gets calculated in the correct way. But this could probably be one cause. So this is culprit number 1 right now. This scaling and offsetting. So then when we have this, so let's assume that we calculate that the correct way. So bounce max and bounce min are now this point and this point in world space. Then we take the brush bounce, min and max, and these are brush position in world space, and then brush radius in X and Y. So yeah, what we do here then is that we calculate, we just do inverse lerp here. So given this position in world space, and we have these boundaries, where are we located in a value between 0 and 1? It's pretty straightforward. This is culprit number 2, but I'm pretty damn sure that it's this one. I think the offset is pretty straightforward. What do we do? Resolution padding. This is 3. We multiply by 0.5, so it's 1.5 times patch dimension divided by resolution. We try to calculate, or this is how big is a pixel in data in world space. But this is only base resolution. Yeah, I think that's... Base resolution is 3 pixels. What do we have here? Half, 1.5, 2.5, 3.5, 4.5. Oh, actually, half, 1.5, 2.5, 3.5, 4. 7 minus 3. So dimension divided by 4. I think this is I think this one is correct. And then we add resolution padding 1.5. Yes, because the offset, we only want this offset, and that's 1.5. So this offset looks to be all right. My question is, do we really need this UV scaling? I don't think we do. We take this point, why the fuck would we scale it? We just move 1/2 pixel, 1 pixel, and then we do the same down here, and we get this one. We don't need to scale it, do we? And then we do the same here, 1/2 pixel, 1 pixel. Yeah, let's test it real quick. Mm-hmm. Okay. Okay. That is so much worse. Seriously? What? What? 1 divided by UV scale. Base resolution, full resolutions. We're talking. We're talking. So in this specific case, we're talking 128 divided by 131. Okay. And then we're doing 1 divided by 0.977. So a scale by 1.02 screwed it up this much. Have I screwed something else up? %. Hmm. Or did I miss something? 2%? How can that lead to such a big difference? UV scale. 1 divided by... What the fuck? Okay, that makes me wonder if... What happens if we do this? %? We still have some weird offset here. Okay, so it's extremely important that the scale is right. I had forgotten how fun it is to look at this scaling. Yeah. Okay. One sec though. We never go below 0 here, do we? We should definitely go below 0 sometimes. Hell yeah. Okay. So if we take a look at this image again. Yeah, we need to scale it, but... Inverse lerp here. Fuck, could this be... Ooh, inverse lerp. One thing, I've done too much shader programming, but if we go to inverse lerp, Unity, okay, nice. Where do we have a value between 0 and 1? We want it to be able to go past 0 and 1, right? So we want to do an inverse lerp that doesn't clamp it. Do we have something like that, or are we gonna have to implement it ourselves? We do have lerp unclamped. That's nice. Inverse. But actually, let's see here. We can just do... what is it? Input divided by max minus min. Is that what we're looking at? I'm just gonna do this. Value minus min divided by max min. Okay. Let's try this and see what we get. Do I have an extension on MathF? Yo, what's up? What's up again, Neozoid? MISC, assigners, builders, colliders, constraints, extension, math. Just math, okay. Yeah, let's do this. Unclamped. Something like that. And then I also want okay. So you should be able to do vector 3. Fuck, this one is a vector 3. Okay, just in this case, I want to support that one as well. But this is weird. Bounce min, bounce max. Okay, so this will probably get rid of the weird scaling we could see at the edges of patches. Or that's what I think, at least. Let's see if that's the case. Let's see if that is the case. So the weird offset is still there, but if we do a very big and we go, oh. Okay. So now I'm wondering. That's almost perfect. Now we only have this weird scaling left. So you can see that even though I... Oh, so close. So close. And yeah, the closer we get to the 0 coordinates, the better it gets, I think. So yeah, scaling. So the further away we get, do we get more offset? I think so. Oh. Okay. Where do we have it? What am I missing here? So we can definitely not, we need to do the scaling, like even though this value is just about, what was it, 1.2, or this is actually 0.2, 0.02, yeah, 2%, it still affects it a great deal. I wonder. Let's take a look at this. So we do, UV scale is 128 divided by 131, 0.977. 1 divided by 0.977, 1.023. In fact, do I need to write this up? Maybe I do. 1.0235. I want to see, what do we get if we do 131 divided by 128? Yeah, that's the same. Bounce min. Still don't understand why offset isn't enough, actually. But but yeah, why isn't offset enough? But I just want to try without the scale again. Now when we have the inverse lerp unclamped, I'm trying to figure out or calculate in my head if it could have caused that big offset we saw. I don't think it could have. Or maybe. Yo, what's up, Spyos? Hope you had a wonderful stream, and thank you for the raid. Always appreciate that. Oops. You too, you too. Okay, so now we try it again without the scale. The scale is only 2%. 2% scaling. Oh, that looks pretty good, doesn't it? It's almost like I don't... I barely want to try it on a seam, but let's... looks pretty good. Looks pretty good, looks pretty good, looks pretty good, looks pretty good. Okay, I think that's it, actually. Do we see some seams? I don't think we do. Okay, if we make this one a little bit smaller and we make it a little bit stronger. Oh, can we... Yeah, we can subtract as well. Damn. Red. Terrain color bottom. Are we actually... Yeah, we're actually going below the... We're representing float values with 16 bits. They are signed, so we can actually go below the boundaries here. That's not good. But that's not a big... Looks pretty cool, actually. That looks insane. Now I just want to get the mesh collider to work as well. But I don't see any seams. Hopefully we won't. So we can try just some noise. And when we cull, we get some weird calculations with the shadow there, but that's okay for now. Or actually, that's not... That's probably... Let me double check one thing. One sec. Yeah, I want to test... I just wonder if it's max defense 1, 10, 20, 50, 60. No. It's probably, most likely, the tessellation. Yeah, we're gonna have to fix that eventually. But this is pretty cool. And no seams anywhere, right? Okay, let's get some collision on this one as well. Collision, currently, it feels like I just have to like state it again. Like, eventually we will use a height collider behind the scenes. Currently, it's represented by a mesh collider. So if we add recalculating the mesh, we're gonna see a pretty brutal performance drop, I think. But as soon as we have the proper height collider in place, it will be okay. Oh, I love this. The tessellation works extremely well as well, but not when we have edges like this over here. So when we have, I guess it's a angle of, I guess it starts to break at like if the angle is 75 degrees or more. I love this. What texture size do we have on this one? This is texture number 4. (128 times 128). Sampler main text. Clamp bilinear. Okay. I wonder how low can we go? Yeah. Okay, let's get some collision on this bad boy. Which I thought we had since we do... Oh yeah, that's true. Okay. Terraform. So what happens is that we change the data and then we try to update the collider, right? The only problem is that we haven't really changed the data until after this one has executed. So I said previously that I like to... It feels more correct to properly populate the command buffer with all the commands, and then we execute them all in a batch. That's not what we're doing currently though, because I worried about this material right here. We can properly set up the properties of this material in a better way, such that or I wonder if we can actually. We use the same material for all of the terraforms. We could, like, what I'm wondering if doing something like set property block would actually fix this. I don't know. But okay, since we're executing the buffer here anyway, I wonder if we want to be as dirty as this. So in Terraform here, we do this. And what we're gonna do now is we're gonna alter something on the GPU, then we're gonna read the full texture back to the CPU, and then we're gonna go through each pixel on that texture on the CPU, fix points on the mesh collider, and then rebake it. Extremely costly. We still don't see an update here. Brush type affects collision. Height true. We have height here. We have update collider. Yeah, we need to do some stuff. Update collider point, update mesh. Do we need to do rebake or update or... I wonder if we could update it async. That would be amazing. One sec. Set vertex buffer data. It could be that the mesh collider doesn't get updated here, but it could also be execute command buffer modify blit dirty true. Dirty is true. And then we execute it, clear it. Then in update collider points, here we do data value. Value. To value multiplier, value normalized. Value normalized. If dirty, fetch data from GPU. Graphics set render target. Yeah. Texture copy, read pixels, source 00, width, height. Am I? Oh, destination X, destination Y. We probably want. No. Read pixels, rectangle source, and then 00, and recalculate mipmaps false. One sec. I'm gonna double check. Height collider. Okay, this is a weird one. We recalculate bounds here as well. Set vertex buffer data. I just want to take a look at the cooking options as well. Hmm. I'm still wondering if this is done first. Could we do... I wonder... I'm gonna try it. If this is just a mismatch, that we update the texture and we read it back, but we read it back too quick, we should be able to... If we do multiple... we can actually see that... It is a little bit slower this time around, isn't it? Not that much, actually. Hmm. We need to reset this one. Okay, I need to print something here. We need to get some actual information out of this. I'm gonna do previous position, new position. Let's see if these calculations fetches data that is new. Do we have that many prints? Did I overdo it? Previous 499. Do we have? They are all pretty much the same. That depends. How many did we change? Yeah, they are. We changed quite a big chunk. Okay, so we just read old values, right? Okay. Definitely want to delete this one. So when we do data value, we read back from the GPU, or I think we do, but we probably don't. Okay, it's very important that value, we do vector2 UV, get index from UV, vector2 int, so it's this one, and then we do this one, and then we do this one, okay. Value, 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 value. Value normalized, do we have value normalized here? Okay. If dirty, fetch data from GPU. Generate secondary data, dirty true. Oh, do we do this one actually? Modify, no we don't. But we do this one. Rect. I want to double check this one. Yeah, but if we increment, we should increment these as well, right? Yeah. Hmm. Oh. We do graphics set render target. Does this one update? When is this one called? Mm-hmm. Mm. Mm. The current statement, blah, 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 blah. Okay. But I don't know. I wonder if this is our problem. Could it be? Yeah, we do this, I'm pretty sure. So I don't know if we need to do this. UV. UV. Do we set these accordingly? UV, yeah, we set it here. Height collider point, UV. We do this. Hmm. Did I double check this one? Immediately, okay. But still. Yeah, but then we double checked it later down the road, and it still hasn't changed the underlying data on the CPU side of things, right? So this might be a little bit of an issue, but that's not the issue we're facing. Affects collision, I'm pretty sure. Terrain data type height, return true. Height collider update. Terrain data container. What the fuck? I don't know. Do I do a fetch before? Execute command buffer. What do we have here? Modify. And we execute, and then we clear it. Do we have anything weird here? Terrain command buffer. Now we don't use it previously to this one. Modify, execute. Okay, my print check wasn't the best one, so let's do this. I just want to make sure if collider points dot y isn't equal to position dot y isn't equal to change detected. Change detected. What the fuck? Quite a few, actually. Okay, that's good to know. Okay. That's good. So, I wonder... Have I forgotten to... render components? Mesh collider... Okay. You know what? I'm thinking about doing... I just want to try and do this. Mesh collider... Mesh... Shared mesh, okay. And then we do update mesh. We don't need to do this one here. Setting the shared mesh, let's see if it triggers something. It does. So now we have... Yeah, now we have some frame drops when we do this. That's okay. Fucking big ones. But that might also be... Let's see if we can just get it down a bit. All of this, temporary. We're gonna move away from the mesh collider eventually. Eventually. That's actually way better. Fuck, extremely quick actually. I'm impressed. But not quick enough. But if we could update it async, it would be, then it would be probably okay. Damn, that's crazy quick actually. Jesus. Now we just need to improve the animator to properly handle this. Okay, that's beautiful. Need to handle that as well. Okay, so now we're back roughly where we were a while back. With the only difference that the behind the scenes here is much better. See if we can add some ambient light here. Yeah, I wanted to double check this one, yeah. Okay. Ambient multiplayer, okay, that's... Ambient won't probably... Yeah, that makes it much worse. One, but shadow multiplier. Oh, that's actually not shadow multiplier, it's... I want to get rid of this blackness here. But we're probably gonna have to alter the ambient. Can definitely fix it, but yeah, we're gonna have to fix it some other way. But that's just a minor detail. I'm a little bit worried about the fact that we are working with values that are not bound to 0 and 1, basically, which means that we can go super deep. Way too deep, actually. With the current shading we have, it almost looks like, yeah, we're down at the core of this. Oh, fuck. Hmm. Hmm. That's not good. But, okay, it might be okay. Index what was outside the bounds of an array. Oh, yeah. Okay. Okay, let me see if I can redo this error. I'm pretty sure I know the reason for it. Pretty sure. Yes. So, terrain patch min index and terrain patch max index. We can end up with indices beyond our terrain patches here. So, position terrain normalized max. This is normalized, right? Transform point to normalized space. Okay, we have to be careful. If we just limit this one to 0 and 1, I'm afraid that that might actually work. We just use this one for terrain patch max index and position terrain normalized. I wonder what happens if this one is 1, then we get patch count X, and that's wrong as well. Floor to int, but if this one is 1, yeah, then we're screwed. We can just add some weird offsets in such a way that we make this one never 1, but we have to be careful with that as well, because worst case scenario we don't include the neighboring terrain patches. I mean, this is a pretty smart way of doing it, except for this fact. less than, and then we do patch count -1 -1. Or we could just clamp it here actually. Or here, that is. Fuck, is that weird? Hmm. If we clamp it, it's like maybe it's okay. So I wonder if we have something like this. Now we clamp it up here. Maybe. Maybe that's okay. It's not done repeatedly. We just add an extra failsafe pretty much. But I guess it's this or actually correcting the maths behind it. First of all, let's see if this even works. Oh, beautiful. And previously we had, let's see here. Okay, that's great. I wonder, let's clean it up and commit this shit. I think we're good. It's gonna be a big commit. Although I wonder, we still have some Terraform data row. Are we using this somewhere? Terraform data, okay. Terraform data. Action interaction Terraform, but this is, I think we have commented this out. Stop alter terrain data. Yeah, we can get rid of this one. Beautiful. And then I wonder, yeah, then we can get rid of this. That's the old solution. Much better now. I wonder, maybe we can make this quit automatically as well when we're done here, eventually. And let's jump here and delete some old files. Terraform data, delete. I don't think we want to package it in a better way. I think it's pretty good as is. It's not too... If we take a look at terrain base, so the full Terraform, which will work with a few other stuff, it's this one basically. Identify terrain patches. That's pretty straightforward. But we can do this. Something like that. Probably do some additional cleanup there, but yeah, it looks hella good. Okay, anything else? And we're gonna have to make the fluid solver work as well. I wonder, we haven't tried this for anything else than height currently. I don't see, I'm very interested in trying this for the foliage as well. Should be pretty, it should work for foliage as well. Let's try it real quick. It's just that we won't render the foliage currently. We need to do a quick fix there as well, or we need to make or alter the system a tiny bit so it works with this new underlying backend. But we should be able to see it. We should be able to see it here. So if we do foliage, okay. Interesting. So let's see why this doesn't work real quick. And we have a lot of prints here. I don't want to print length, height, collider, yeah. So, okay, I might know why it doesn't work. Action, interaction, terraform. Update terraform type. Change brush mode, delta sign. Brush color right, mask shaders. Oh, yeah. Type. Yeah, we just change color right mask currently. We don't do anything else. But still, okay, I know. So we change color right mask, which means that this one gets changed. So instead of writing to the, or we start writing to the green channel instead, I think. So this is the old system where we had height and foliage existing in the same texture. We don't anymore, so we need to handle that. Should be pretty straightforward. So basically what we do, I think, is we do actually terraform. We do change the correct data, but we try to alter the green channel for something. We try to alter the green channel on a data that doesn't have a green channel. Okay. And still, I'm still a little bit, I don't like this at all, this right here. Eventually, we're probably gonna go with graphics format R616 unorm. But to be able to do that, I need to fix, when we try to read this on the CPU, we always read it as a float. We get some problems there. Unfortunately, we don't have R32 unorm. I wonder why. I wonder why. But okay, let's see here. And something like that. Okay, so that's probably what we're gonna do tomorrow, because I need to run now, unfortunately. But feels good, feels good. Feels good to have the terraforming in place once again. And it works so much better this time around. It's not even close. Still very much impressed about the Collider update, that it's so quick. Yeah, but anyway, that's going to be it for today. Thank you so much for watching, everybody. Appreciate it, and have a great rest of the day. Peace.